Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to define what a sector of a circle is, go over the formula used to calculate the area of a sector, and then complete some example problems. Let's begin by noting that the area of a circular sector is important, since sectors can represent portions of circular objects. The easiest one to envision is a slice of pizza. Here's a picture of a sector of a circle. A sector is a portion of the interior of a circle intercepted by a central angle. We'll let theta be our central angle, and we'll add that to our picture. So that angle is theta. And then we'll also include our radius, because we're going to need that variable when deriving our formula. And then we'll also assign a letter to the area. So we'll let A be the area of the sector. And the A, or the area, is highlighted in yellow. Since A and theta are directly proportional to each other, which means as one increases, the other increases. So for instance, as our angle increases, our area is also going to increase. When we have a direct proportional relationship between two variables, we can write A over theta, which means A is to theta as, which we'll indicate by our equal sign, the formula for the area of a circle, which is pi r squared, divided by theta, and theta for the entire area of a circle is going to be 2 pi. So if our area is pi r squared, our theta is equal to 2 pi. And this will enable us to find the formula for A. So let's go ahead and let's now solve for A. So we'll multiply both sides of the equation by theta. So we get A is pi r squared over 2 pi times theta. We'll then notice that our pi's are going to cancel out. So that leaves us with A is equal to 1/2 r squared theta. And that's the formula for the area of a sector. So let's go ahead and let's put that in our box. And that's a good formula to memorize. One thing we need to note before we go on is that theta must be in radians, because r is a distance and our units have to match up. So let's make a note of that. So theta must be in radians. Let's now complete some example problems. In our first problem, we're asked to find the area of a circular sector formed by a central angle of 3 pi over 4 if the radius of the circle is 72 feet. Let's begin by drawing our radius and our angle theta. So here's our radius, and our angle theta, let's see, theta is 3 pi over 4. So we'll draw it like this, and we'll write down what theta is. So that's theta. And then we can also go ahead and let's highlight our sector so we know what we're calculating. So our sector is highlighted in yellow. It's always good to write down the information that we're given in the problem. So let's go ahead and write that down. So theta is pi over 4. I'm sorry, theta is 3 pi over 4. And r is 72 feet. And it's always good to include units with that. To find the area of a sector, we begin by writing down our formula. So we have A is 1/2 r squared theta. And now we can go ahead and plug in our values. So we have 1/2, we plug in r is 72 feet. Go ahead and include the units there. And then our theta is 3 pi over 4. So our theta is already in radians, so we don't have to convert it. So we can multiply these numbers out with our calculator, and we end up with 1944 pi feet squared, which is called square feet. And then if we multiply the pi times 1944, we end up with 6,107.26 square feet. So we'll write that as feet squared. And it's always a good idea to box your answers. So let's go ahead and let's box our answer. Okay, great. So we have that first problem completed. In our second problem, we have a circle with a radius of 6 inches, and we're asked to find the area of a sector if its central angle is 60 degrees. So just like we did in our first problem, let's write down the radius in our picture. And let's see, our angle 60 degrees. So it's going to look like this. And we'll label this as r and theta. And then the last bit is we'll highlight the area of the sector that we're being asked to find. We'll begin by writing down what we have been given. So we have a radius of 6 inches, and we have an angle theta of 60 degrees. And we will have to convert that to radians in a few minutes. So we'll start with our calculation again with writing down our formula. A is 1/2 r squared theta. And now we can go ahead and plug in our values. So we have 1/2. Our r is 6 inches. And we square that. And then our theta is 60 degrees. Now here is where we're going to make our conversion. We need to convert 60 degrees to radians. So we're going to multiply by pi over 180 degrees. I have a video on converting between degrees and radians if you need to go and review that concept. So let's see here what's going to cancel. It looks like our 60 can go into our 183 times. And then on the bottom, we're going to have a 6, and on the top we have a 36. So this ends up being 36 divided by 6. So this is 6 pi inches squared. And then we can throw that into our calculator, and we end up with 18.85 inches squared, or square inches, which makes sense because area is always in terms of a unit squared. And let's go ahead and we'll finish by boxing our answer. You should now be ready to calculate the area of a sector on your own.